Hello friends, welcome back. In previous tutorial we studied how we constructed the action table and Goto table for SLR1 parser, and we also studied how these action table and Goto table were used for parsing a given string of tokens. How these tables, action table and Goto table, were used for syntax analysis. So in this tutorial we are going to study about a new bottom-up parser called LR1 parser. So this LR1 parser is a bottom-up parser, right? So for this what we need to do in this tutorial, we will learn how we can construct the action table and Goto table for this LR1 parser, and how these action table and Goto table are used by this LR1 parser for the syntax analysis of given string of tokens. Now consider this grammar. Suppose this grammar is given to us and we need to construct the action table and Goto table of LR1 parser for this given grammar. So what we need to do, first we will augment this grammar, right? So for augmenting this grammar, what we need to do, we need to add a production rule. S1 derives S, where S is the start symbol of this original grammar, right? So to augment this grammar, what we need to do, we need to add a new non-terminal symbol, that is S1, and apart from this we need to add a new production rule also. S1 derives S, right? Rest of the production rules will remain same, right? Now this is the augmented grammar. So as we studied in SLR1 parser, before constructing the action table and Goto table, we had to construct a DFA, right? So in LR1 parser also, first of all we had to construct a DFA, and the state of that DFA will be a set of LR1 items, right? In SLR1 parser, the state of DFA was a set of LR0 items, right? So what are these LR1 items? One LR1 item consists of one LR0 item and a look ahead symbol, right? Here you can see this LR1 item, right? It consists of this LR0 item and this look ahead symbol, right? So it will be more clear later what are these LR1 items, right, and what are these look ahead symbols. It will be more clear, right? So as in SLR1 parser, right, to construct the DFA we had to be aware about two functions, closure function and Goto function. So what is this closure function? Suppose we need to find the closure of this LR1 item, right? So what will happen whenever we find a closure of LR1 item? What does it mean? So first of all you must know that a closure of LR1 item will be a set of LR1 item, right? It will be a set of LR1 items. So in that set, first of all, that item whose closure we are going to find, that itself will be added. So here we are going to find the closure of this LR1 item. A drives alpha dot B beta and look ahead symbol A, right? We have to find the closure of this LR1 item. So in the closure of this LR1 item, first of all this item itself will be added. So I will add this item in this set, right? Because closure of an item is a set of items. A drives alpha dot B beta and look ahead symbol A, right? Now whenever I add an item in this closure, what I need to do, I need to check the position of dot, right? So if dot is preceding any non-terminal symbol, then I will add all the items in the closure in which this non-terminal which is following the dot is at left side, right? And on right side the dot is at leftmost position, right? Suppose in augmented grammar there is some production rule, B derives gamma, right? So corresponding to that we will add this item, B derives dot gamma, right? Here you can see in this item this non-terminal B is at left side, right, and at right side the dot is at leftmost position. Now what would be the look ahead symbol for this item? Now see here, we have added this item because of this item, right? We have added this item because of this item, and in this item you can see that this non-terminal symbol B is following the dot, and after dot there is a string beta, right? There is a string beta. So and look ahead symbol is A. So the look ahead symbol of this item will be first of beta A, right? Look ahead symbol of this item will be first of beta A, right? So here again what we need to do, again we have to check the position of dot, right? So in this newly added item, again we have to check the position of dot. So if in this newly added LR1 item, if this dot is preceding some non-terminal symbol, then again we will repeat the same process, right? So we will keep on adding these LR1 items in the closure as long as possible. Now next is the Goto function. See what happens in a Goto function. Now Goto function is used to find the transitions of state of DFA on a particular symbol, right? Suppose there is some state of DFA, that is I0, and there is some symbol X. If the output of this function go to I0X is I1, then it means when the DFA is in state I0 and it reads the symbol X, then it will jump to state I1, right? If go to I0X is equal to I1. So what happens, this Goto function specifies the transitions in DFA. Now how we evaluate this Goto function? Suppose there is some state of DFA, right? As I told you that a state of DFA is a set of LR1 items, right? Suppose there is a state of DFA I0 and it is the set of these LR1 items, right? Now we have to evaluate go to I0A, right? Go to I0A. Now we need to find out what would be the next state, right, of DFA when it is in state I0 and it reads the symbol A. So how we find it? So first of all, in this state I0 we will check all the LR1 items, right? We will check all the LR1 items in which the dot is preceding this symbol A, right? So here only in this LR1 item you can see that dot is preceding this non-terminal symbol A. So what we will do, we will shift this dot to the right of this non-terminal symbol A, right? Like this. Here we have shifted this dot to the right of non-terminal symbol A, and then we will take its closure, right? Then we will take its closure. So this will be the output of this Goto function for input I0 and A, right? So go to I0A will be the closure of this LR1 item. Consider this augmented grammar. We need to construct the DFA for LR1 parser for this augmented grammar, because we need to construct the action table and go to table for the LR1 parser for this grammar, right? So what we need to do first, we need to construct the DFA. So by using this augmented grammar, we have to construct a DFA. So first we will write the initial state of DFA. Let the initial state of DFA is I0. So what would be the initial state of DFA? As I told you earlier that each state of DFA will be a set of LR1 items. So initial state of DFA will be the closure of this LR1 item. S1 derives dot S and look ahead symbol is dollar, right? So initial state of DFA will be closure of this item, right? So what would be the closure of this item? The closure of this item will be a set of items, right? So first this item itself will be added in its closure. So in the closure of this item we will add this item S1 derives dot S look ahead symbol dollar, right? Now we will check the position of dot in this item. So here dot is preceding this non-terminal symbol S. So what we will do, we will add those items in which this non-terminal symbol S is at left, right, and the dot at right is at leftmost position. So see these two production rules. So corresponding to these production rules we will add items in the closure, because in these production rules you can see that this non-terminal symbol S is at left. So we will add these items as derives dot a b and as derives dot b a. Right, so here you can see that this non-terminal as is at left and at right the dot is at leftmost position. Now what would be the look ahead symbols for these items? Now we have added these items because of this item. Right, now you can see that there is no symbol is following this symbol S in this item. In this item you can see this non-terminal symbol S, it is not followed by any symbol. So in that case what happened, what would be the look ahead for these items? It would be the first of, now see, this is the look ahead symbol for this item, first of dollar, and it will be equal to dollar itself. So the look ahead symbol for these items will be dollar. See, these two new items have been added. So in this newly added items we need to check the position of dot. So first I will check the position of dot in this newly added item. So in this item you can see that dot is preceding this non-terminal symbol A. So I need to add more items also, right? I need to add an item in which this non-terminal A is at left side, right? So corresponding to this production rule I will add this item A derives dot, right? So here you can see that this non-terminal A is at left and at right the dot is at leftmost position, right? Now I need to find the look ahead symbol for this item. Now see here, I have added this item because of this item, right? Now in this item you can see this dot is followed by this non-terminal A. Now the string of terminals which are following this non-terminal A is this AAB, right? AAB, and this dollar is the look ahead symbol. So first of AAB dollar will be the look ahead symbol for this item. So it is first of AAB dollar, it is equal to a set having only one element, that is terminal symbol A. So terminal symbol A is the look ahead symbol for this item, right? Now again I will check this newly added item, right? In this newly added item you can see that the dot is preceding this non-terminal symbol B. So for that, corresponding to this production rule where this non-terminal symbol B is at left, I will add this item B derives dot, right? Now what would be the look ahead symbol for this item? Now see here, I have added this item because of this item. In this item you can see that B is followed by this string of symbols B, B, A, and look ahead symbol here in this item is dollar. So the look ahead symbol of this item will be the first of BBA dollar, first of BBA dollar, right? And first of BBA dollar will contain only one terminal symbol B, right? So look ahead symbol of this item will be terminal symbol B. Now here I have added these two new items. Now in these two items I will check the position of dot. So here you can see that dot is not preceding any non-terminal symbol. So no new items can be added in this set, right? So here in this way we have found the closure of this item, and this set is the initial state of DFA I0, right? Now what I need to do, I need to find the transitions of this state I0. So here you can see the items of this state I0. In these items the dot is preceding only the symbols S, A and B, right? Here in these two items the dot is not preceding any symbol. So here for this state I0 we need to find the transition only for these three symbols, right? That is S, A, B, right? So first I will find the transition of this state I0 for non-terminal symbol S. So for that I need to evaluate the function Goto I0s, right? So what would be the output of go to I0s? Now see, in this state I0, see the item where dot is followed by non-terminal symbol s. Here you can see that there is only one item where dot is followed by non-terminal symbol s. So in this item, what I do, I will shift this dot at the right of non-terminal symbol s, right? So in this item, I will shift this dot at the right of non-terminal symbol s, right? Then I will get this item. Now what I need to do, I will take closure. So closure of this item, right, will be the output of this goto function, right? So now we have to find the closure of this item. First, in the closure of this item itself will be added as one derives as dot look ahead symbol dollar. Now here you can see that no new symbol can be added, right, because this dot is not followed by any non-terminal symbol, right? Here in this item you can see that the dot is not followed by any non-terminal symbol, so no new item can be added in this closure. Now suppose this set is called I1, right? So this is the state I1 of DFA. So go to I0s is equal to I1. So it means when the DFA is in state I0 and it reads this non-terminal symbol s, then it jumps to state I1. So here is this transition diagram, right, for the DFA. Now we will find the transition of state I0 for non-terminal symbol A. So for that I'll evaluate go to I0A, right? So for that what I will do, I'll check this state I0. In this state I0, I will find that item in which dot is followed by non-terminal symbol A. So here in this item the dot is followed by non-terminal symbol A. So in this item what I do, I will shift this dot at the right of non-terminal symbol A. So then it will be as derives A dot AAB, right, and look ahead symbol is dollar. Now what I need to do, I need to find the closure of this item, right? So what would be the closure of this item? First, this item itself will be added in its closure. So as derives A dot AAB, look ahead symbol dollar. Now we have added this item in the closure. So here you can see that dot is not followed by any non-terminal symbol. So no new item can be added here in this closure, right? So this closure will contain only this single item. Let this set is I2, right? So this is the another state of DFA I2. So go to I0A is equal to I2. It means if DFA is in state I0 and it reads the symbol A, then it will jump to state I2. So in transition diagram I have shown this transition from state I0 to I2, right, for this non-terminal symbol A. Now we will find the transition of state I0 for non-terminal symbol B, right? So for that we need to evaluate this goto function. So in state I0 we will find that item where dot is followed by this non-terminal symbol B. So in that item we will shift this dot at the right of non-terminal symbol B, right? So we will get S derives B dot B B A look ahead symbol dollar, right? And then what we will do, we will find its closure, right? So the go to I0B, it will be the closure of this item. So we need to find the closure of this item. So first of all, that item itself will be added in its closure. So this item as derives B dot B B A dollar, this will be added in this set, right? This will be added in closure. Now we have added this item. Now we will check the position of dot. You can see that dot is not followed by any non-terminal symbol, so we cannot add any more items in this set, right? So this set will have only one item. So let this set be I3, right? So what it means, if the DFA is in state I0 and it reads this non-terminal symbol B, then it jumps to state I3, right? I3 is a state of DFA. So in transition diagram I will show it like this. If the DFA is in state I0 and reads the non-terminal symbol B, then it will jumps to state I3, right? Now we will find the transition of state I1. Now see here, see this state I1, this is state I1, this is having only one item, and here you can see that dot is not preceding any symbol in this whatever the item is there in state I1, right? In those items the dot is not preceding any symbol, so we cannot find any more transition of this state I1, right? So what I'll do, I'll find the transitions of state I2, right? So in state I2 you can see the dot is preceding this terminal symbol A, so we can find the transition of state I2 only for this terminal symbol A, right? So now I will find the transition of this state I2 for terminal symbol A. So for that I need to evaluate this function, go to I2A, right? So for that I need to find those items in I2 where the dot is preceding this terminal symbol A. So here there is one item where dot is preceding this terminal symbol A, right? So what I will do, in that item this dot will be shifted at the right of terminal symbol A, right? Then I will get this item as derives A dot A B, look ahead symbol dollar, and then I will take its closure, right? This is the output of go to I2A, right? So in the closure of this item itself will be there, right? Now here we have added this item. Now in this item you can see that dot is preceding this non-terminal symbol A, right? So we will add the item in this closure for this non-terminal symbol A corresponding to this production rule, right? A drives empty, right? Where this non-terminal A is at left and at right the dot is at leftmost position. So corresponding to this production rule, A drives empty, I have added this item, A drives dot, right? Now what would be the look ahead symbol for this item? So here you can see that a dot is followed by terminal symbol A, right, in this item, right? Because this item is added only because of this item. So in this item you can see the dot is followed by terminal symbol A, right? That's why we have added this item. And after A in this item there is a string, right, having only one symbol, that is B, right? So what we need to do, we need to find the first of B and look at after that look at symbol dollar, first of B dollar, and you will see that first of B dollar will contain only one terminal symbol, that is B, right? So the look ahead symbol for this item will be terminal symbol B, right? Now again we have to check the position of dot in newly added item. So here you can see that dot is not preceding any non-terminal symbol, so no new item can be added, right? Now suppose this is the state I4 of DFA, right? So when the DFA is in state I2 and reads the terminal symbol A, it jumps to state I4. So here I have shown it in transition diagram. Now let us find the transition of state I4. Now see that in state I4 whatever the items are there, in them dot is preceding only the non-terminal symbol A. So here we can find transitions of this state I4 only for this non-terminal symbol A. So we have to evaluate go to I4A, right? So in that case what will happen? in state I4 we will find the item where the dot is preceding this non-terminal symbol A, and then this dot will be shifted to the right of non-terminal symbol A in that item, and then we will find the closure of that item. So go to I4A, it will be equal to the closure of, now see this item in a state I4, here dot is preceding this non-terminal symbol A. So what we will do, we will shift this dot at the right of non-terminal symbol A, right? Then we will get this item, right? So we need to find the closure of this item. So in the closure of this item itself will be added, right? Now here we have added this item. Now in this, if we check the position of dot, you can see that the dot is not preceding any non-terminal, so no new item can be added in this set, right? So let this set is the state I5, right? So this set is having only one item. This is the state I5. So when the DF is in state I4 and it reads the non-terminal symbol A, then it jumps to state I5, right? Now we need to find the transition of this state I5. Here you can see in state I5, whatever the items are there, in them dot is preceding only the terminal symbol B. So we can find transition of this state I5 only for terminal symbol B. So what we need to do, we need to evaluate this Goto function, go to I5B, right? So it will be equal to what? So we will find that item in I5 where the dot is preceding this terminal symbol B, right? And then that dot will be shifted to the right of terminal symbol B in that item, and then we will find the closure of that item. So it will be the closure of S derives A B dot, look ahead symbol dollar, right? So here you can see that in this item the dot was preceding the terminal symbol B, so we have shifted it to the right of terminal symbol B in this item, right? And then we have taken its closure. So we need to find the closure of this item. So first of all, this item itself will be added in its closure. S derives A B dot, look at symbol dollar. Now here you can see the position of dot. The dot is not preceding any non-terminal symbol, so no new item can be added in this set, right? So this set is having only one item. Let this set is I6, right? This is the state I6 of DFA. So when the DFA is in state I5, right, and it reads the terminal symbol B, then it jumps to state I6, right? So here I have shown this in transition diagram. Now you can see the state I6. In state I6, the dot is not preceding any symbol, whether it's terminal or non-terminal. So whatever the items are there in state I6, in them dot is not preceding any symbol. So we cannot find any more transition for this state I6, right? So what we will do, now we will find the transitions of state I3. Now we need to find the transition of this state I3. So here you can see whatever the items are there in I3, in them the dot is preceding only the terminal symbol B. So we can find the transition for I3 only for this terminal symbol B. So for that we will evaluate this function, go to I3B, right? So what we will do in I3, wherever in items dot is preceding the terminal symbol B, the dot will be shifted to the right of terminal symbol B in that item, and then we will find its closure. So it will be equal to the closure of, now see this item here, dot is preceding this terminal symbol B, so this dot will be shifted to the right of terminal symbol B. So the closure of S derives B dot B A, look ahead symbol dollar. Now in the closure of this item, first of all, that this item itself will be added. S derives B dot B A, look ahead symbol dollar. So here now you can see that dot is preceding this non-terminal symbol B. Right, so here you can see this production rule in the augmented grammar, b drives empty. So corresponding to this production rule, we will add the item, right, in which this non-terminal b is at left side, right, and at right side the dot is at leftmost position, right. Now what would be the look ahead symbol for this item? Now see, this item we have added because of this item, right, and in this item after dot you can see there is non-terminal symbol b, and after b there is a string having symbol a, right. So the string having symbol a, right, then we will write after that dollar, right. So look ahead of this item will be first of a dollar, right, first of a dollar, and it will be first of a dollar will contain only one terminal symbol, that is a, right. So look ahead symbol for this item will be a, right. Now you can see that to this newly added item we will check the position of dot, right. So here dot is not preceding any symbol, right. So you can see that dot is not preceding any non-terminal symbol, so no new item can be added in this set, right. So this set will have only these two items. Let this be the state I7 of DFA, right. Let this is the state I7 of DFA. So in DFA I will show this transition go to I3B is equal to I7. So when the DFA is in state I3 and it reads the terminal symbol B, then it jumps to state I7. Now I have to find the transitions of state I7. So in state I7 whatever the items are there, in them the dot is preceding only the non-terminal symbol B. So we can find the transition of I7 only for non-terminal symbol B. So for that I need to evaluate this function go to I7B. So whatever the items are there in I7 where dot is preceding non-terminal B, then what we will do in those items, what will be done, this dot will be shifted to the right of non-terminal B, right. So in this item you can see dot is preceding B, so it will be shifted to the right of non-terminal B. So I will get this item as trash BB B dot A, and look ahead symbol will be the dollar, right. I need to find its closure. So in the closure of that, first of all this item itself will be added, that is as derives B B B dot A, look ahead symbol dollar, right. So here you can see that dot is not preceding any non-terminal symbol, so no new item can be added in this closure. So this closure is having only this item. Now let this set is state I8 of DFA, right. So go to I7B is equal to I8. So when the DFA is in state I7 and it reads this non-terminal B, then it jumps to state I8, right. Now I need to find the transition of state I8. So here you can see that in state I8 that dot is preceding only the one symbol, that is terminal A, right. Whatever the items are there in I8, and then dot is preceding only one symbol, that is terminal A. So for state I8 we can find transitions only for terminal symbol A. So for that I need to evaluate go to I8A. So in state I8 in items where dot is preceding this terminal symbol A, that dot will be shifted to the right of terminal A, and then we will find its closure. So we have to find the closure of as derives B B B A dot and look ahead symbol dollar, right. Here in I8 dot was preceding A, we have shifted it to the right of A, right, and then we need to take the closure of that item. So first the item itself will be added in the closure, that is as derives B B B A dot look ahead symbol dollar. Right, now here this item has been added in the closure. Now in this item you can see that dot is not preceding any non-terminal. Right, here you can see that dot is not preceding any non-terminal, so no new item can be added in this closure. Let this set is I9. Right, it is the state I9 of DFA. So go to I8, A is I9. So when the DFA is in state I8 and it reads the terminal symbol A, then it jumps to state I9. Right, so here in this way we have constructed this DFA. Right, now by using this DFA, what we have to do, we have to construct the action and go to table for LR1 parser. Now by using this DFA, we need to construct the action and go to table for this LR1 parser. So what happens in this action and go to table? In action and go to table, in both, the rows are labeled by the name of states of DFA. So here in this case we are having the states from I0 to I9. Right, we are having the states I0, I1, I2, I3, so on up to I9. So in both action table and go to table of this LR1 parsers, the rows are labeled from I0, I1, I2 like this, so on up to I9. Right, now the columns in action table, they are labeled by terminal symbols and dollar symbol, whereas in go to table the columns are labeled by non-terminal symbols. Right, now see what we need to do. To the production rules of the grammar, we need to assign a number. Right, so to this production rule I have assigned the number 1. To this production rule I have assigned the number 2. To this I have assigned the number 3. To this I have assigned the number 4. So this is the production rule number 1, this is the production rule number 2, this is the production rule number 3, and this is the production rule number 4. Now how do we fill this action table and go to table by using the DFA? So first of all we will fill the action table. Right, now these are the rules for filling the action table. So let us see the first rule. What it say? If the state II of DFA contains this item S1 derives as dot look ahead symbol dollar, then in action table at row labeled by II and column labeled by dollar we will write except. Right, so here you can see that in this DFA, this is state I1, it contains this item. Right, it contains this item S1 derives as dot look ahead symbol dollar. So what happens in action table at row labeled by I1? Right, because I1 contains this item. In action table row labeled by I1 and column labeled by dollar symbol, we will write accept. Right, now see the second rule for filling this action table. For every terminal symbol A, if go to I, A is equal to IJ. Right, it means if for any terminal symbol A, the DFA jumps from state II to state IJ. In that case, in action table at row labeled by II and column labeled by terminal symbol A, we will write SJ. Right, now see in this DFA you can see that if the DFA is in state I2 and it reads this terminal symbol A, then it jumps to state I4. So what we will do in action table at row labeled by I2 and column labeled by terminal symbol A, we will write S4. It means shift and jump to state I4. Right, here you can see that when the DFA is in state I2 and it reads A, it jumps to state I4. So in row labeled by I2 and column labeled by terminal symbol A, we have written S4. Similarly, see the other transitions for terminal. Here you can see when the DFA is in state I3 and reads the terminal symbol B, it jumps to state I7. So in row labeled by I3 and column labeled by terminal symbol B, we will write S7. Right, because from I3 for terminal symbol B there is a transition to state I7. So in row labeled by I3 and column labeled by terminal symbol B, we have written S7. Right, now here you can see the transition from state I5 to state I6 for terminal symbol B. So in row labeled by I5, right, and column labeled by terminal symbol B we will write S6, right. It means shift and jump to state I6, right. Here see this another transition for terminals. Now see this transition from state I8 to I9 for terminal symbol A. So when DFA is in state I8 and it reads the terminal symbol A, it jumps to state I9, right. So in row labeled by I8 and column labeled by terminal symbol A, I'll write S9, right. Now third rule for filling this action table: if state II of DFA contains an item of this form, A drives alpha dot, right, and look ahead symbol A, right. It means if any state of DFA which contains an item like this, in which at right side the dot is at rightmost position, right, then what we will do, right. So what happens if state II of DFA contains an item of this form, A drives alpha dot, look ahead symbol A. So what we will do in this case? In this case, in action table at row labeled by II and column labeled by terminal symbol A, right, where terminal symbol A is the look ahead symbol of this item, right. In that entry we will write RK, right. What is this K? K is the production rule number of this production rule, A drives alpha, right. It will be clear. Now let us see this state I6. In this state I6, in the item, what happens? This dot is at rightmost position, right. Now see this item is S drives AAAB, right. S drives AAAB. So what is the number of this production rule? The number of this production rule is 1, right, and look ahead symbol is dollar, right, and it is in state I6. So what happens in action table at row labeled by I6, column labeled by dollar, I will write R1, means reduction by production rule number 1. Now you can see that this is the production rule number 1, as drives AAAB, and the dot is you can see in this item which is in state I6, the dot is at rightmost position at right side, right. So in state I6, column labeled by dollar, right, I will write R1, right. Now see here the state I9. In state I9 also we are having an item in which the dot at right side is at rightmost position, right, and look ahead symbol is dollar, right. And now you can see this item S drives BBBA, right. So the production rule S drives BBBA, it is a production rule number 2, right. So in row labeled by I9 and column labeled by dollar, I will write R2, means reduction by production rule number 2, right. So in row labeled by I9 and column labeled by dollar, right, I'll write R2. Now you can see this state I4 here. See this item A drives dot, right. In this item you can see that at right side the dot is at rightmost position, right. So you can see this production rule A drives empty, because this item A drives dot, it is corresponding to this production rule A drives empty. The number of this production rule is 3. So what happens in state I4, we contains this item A drives empty, look at symbol P. So in action table at row labeled by I4 and column labeled by terminal symbol P, we will write R3, means reduction by rule number 3, right. So in I4 row, right, and column labeled by terminal symbol P, I'll write R3, right. Now see, this is the production rule B drives empty, right. B drives empty, not A drives empty, right. This is the production rule number 4. Now let us see this state I7. In this state I7, we are again having a item where at right side the dot is at rightmost position, that is B drives empty. Look ahead symbol is E, right? And this item is corresponding to this production rule. B drives empty, that is production rule number 4. So in row labeled by I7 and column labeled by terminal symbol A, I will write R4. Right. Now in state I0 also we are having these two items where the dot on right side is at rightmost position. These two items, A drives dot and P drives dot, these are in state I0, right? And their look ahead symbols are A and B. So now see this item A drives dot, right? A drives dot is corresponding to this production rule, rule number 3, right? So in action table at row labeled by I0, right, and column labeled by terminal symbol A, I'll write R3. Now see this another item in I0, B drives dot, its look ahead symbol is B. So in action table at row labeled by I0, column labeled by B, right, I'll write R4 because this item B derives dot, it is corresponding to this production rule B drives empty, which is the production rule number 4. Right. Now what we need to do, now we need to fill the Goto table, right? Now we have to fill the Goto table. Now how we can fill the entries of Goto table? So what happens in a DFA, if for any non-terminal A there is a transition from state II to state IG, then what we will do in Goto table at row labeled by II and column labeled by non-terminal symbol A, we will write J, right? It will be clear here. Now here you can see for this non-terminal S, right, there is a transition in DFA from state I0 to state I1. So what we will do in Goto table at row labeled by I0 and column labeled by S, I will write 1, right? Row labeled by I0, column labeled by S, I will write 1. Similarly, you can see for non-terminal A, there is a transition from I0 to I2, right, for non-terminal symbol A. So in row labeled by I0 and column labeled by non-terminal A, I will write 2. Now here you can see another transition of state I0 for non-terminal symbol B, right? So on reading non-terminal symbol B, the DFA jumps from I0 state to I3. So what we will do in Goto table at row labeled by I0 and column labeled by non-terminal B, we will write 3. Now see this transition for non-terminal symbol A from state I4 to I5, right? So here from state I4 there is a transition to state I5 in DFA for non-terminal symbol A. So in Goto table at row labeled by I4 and column labeled by non-terminal symbol A, I will write 5, right? So here see the another transition in DFA, right? Now here there is a transition from state I7 to state I8 for non-terminal symbol B, right? So in this case what we will do in Goto table at row labeled by I7 and column labeled by non-terminal B, right, I will write 8. Right. So in this way we have filled both action table and Goto table.